So today we're talking about prime factorization. And there's a couple things you need to know before we get into actually factoring problems, which is what we're going to do primarily. But the first thing is prime numbers. There's two types of numbers. There's prime numbers and there's composite numbers. So prime numbers are whole numbers that have exactly and only two factors. So when we talk about prime and composite numbers, we have to think about multiplication. So here are some examples. The number 13. The only two things I can multiply together to get 13 are what? Yes, 1 and 13. That makes 13 a prime number because the only thing you can multiply to equal that number is 1 and itself. Another example would be the number 5. The only two things you can multiply to get 5 are what? 1 and 5. Also 7 or 17 or 19. So depending on how far you want to go with math, there are math classes where you actually kind of memorize all the prime numbers because you work so much with them that you just kind of learn them. But there are quite a few prime numbers, and they go all the way up, like they get really large. But a prime number is a number that can only be multiplied by 1 and itself. So a composite number is going to be the opposite of that. It has more than two factors. And there's going to be lots of examples of composite numbers. So it's any number that you have more than two factors. The number 8. I can multiply 1 and 8 to equal 8. And I can also multiply 2 times 4 to equal 8. So that makes it composite now because it has more than two factors. How about 12? Well, for 12, I can multiply 1 times 12. What else can I multiply?
4 times 3 times 6.
4 times 3 and 2 times 6. Good. How about 24? What is it?
8 times 4. Wait, no.
Yeah, hold it.
6 times 4.
6 times 4. What else? Come on, Jeremiah. What else? Anybody?
12 times 2.
12 times 2. What else? Okay, I'll give you one. 3 times 8.
So there was one with the 3.
Yeah, there was one with a 3. Okay, so composite numbers have more than two factors. Prime numbers only have two factors, 1 times itself. So prime factorization is the thing we're going to work on now, and all that means is that you're finding all the prime factors of a composite number. So another way to think of it is you're finding the very smallest factors of a number. And I'm going to show you how that works right now. So when we do factoring, we usually start with a number that is composite. That means it has more than two factors. And what I'm going to do is I'm going to find some numbers that equal that number. So I'm going to start with 6 and 6, but you could start with 3 and 12. Whatever you want to start with, you're still going to get the same answer as me. So I'm going to do 6 times 6, and I'm going to make a factor tree. This is called a factor tree because it has a bunch of branches, and you'll see once we're done. There's another way to factor 2. It's called cake, and I can show you that way as well in a minute. So I know that 6 times 6 is 36. What numbers equal 6? 3 and
3.
if I'm multiplying. 3 and 2. Okay, and I'm going to break this 6 down as well. So the prime factorization of 36 is going to be these numbers. Because these numbers are prime, I can't break them down anymore. And so my prime factors for 36 will be 2 times 2 times 3 times 3. So this one that we just did is called a factor tree because it has all those little branches coming off to show us all the different factors. Another method is using the cake method. If anyone has Miss Forrester at some point, she uses the cake method. So I want to show you both ways to do it. So when I use the cake method, I want to pick a prime number to go out here on the side. So I'm going to pick 2 because I know 2 is a very small prime number. And 2 goes into 36 how many times?
8.
13.
You're close, Holden.
14.
18.
18.
Yes, sir.
No, hold on. It is 18. Did somebody say 18 already? Sorry, that was right. Okay, so 18. So 2 times 18 is 36. And we're going to do another layer on our cake. So again, I'm going to use the number 2. That's the number I use the most often because it's easiest and it's prime. And how many times does 2 go into 18? 9. Make another layer. Now 2 won't go into 9, but what small number will go into 9? 3. And how many times will 3 go into 9? 3 times. Now, does anything go into 3 besides 1 in itself? Just 1 in itself. So we're done. So if I bring down all those prime factors that are sitting around my cake, I get the same answer as I did when I used the factor tree. Because the prime factors of 36 are 2 times 2 times 3 times 3. And if you use your calculator, which is not showing up, if we do 2 times 2 times 3 times 3, we get 36. All right, so that's how you can check if you did your prime factoring right. You multiply them all back together and see if you get the number that you started with. So to factor a number means that you write the number as a product of its factors. So if we look at this example, I want to write this number as a product of all its prime factors. So the first thing I'm going to do is I'm going to factor 8. What equals 8? 4 and 2. Now 2 is prime, so that one's done, but 4 is not. So what equals 4? And 2. So the factors of 8 are what? 2 times 2 times 2. It's going to be all your prime numbers. Those are all going to be the factors of 8, okay? So if I write this as its factors, I'm going to write 2 times 2 times 2. And then how many x's do I have if I have x squared? Say it again.
4.
Nope. 2. X squared means I have x times x. So to write 8x squared out in its factors, I'm going to write 2 times 2 times 2 times x times x. And if I were to multiply all that together, it would come back to equal what I started with. One more thing, when you're writing out your prime factors, if we go back up here to this example, I can write them using exponents. So that you don't have to do like 2 times 2 times 2 times 2 times 2 times 2 times 2. Like what if you have a really big number and there's a lot of 2's? You don't want to write 7 or 8 2's out, right? So we can write it with exponents like we learned in the last section. So how many 2's do I have right here?
3,
Right here?
2,
2. And then how many 3's do I have? 2. So if I write that as exponents, it would be 2 to the second power times 3 to the second power. For numbers 4, 5, and 6, it says write whether the number is prime or composite. So to figure out if it's prime or composite, I'm going to see how many factors it has. Remember, prime has how many factors? 2, and composite has more than 2. So what are the factors of 7? 1 and 7. Anything else? So what is this number? Prime. Good. It only has 2 factors, so it's prime. What are the factors of 23? 1 and 23. Anything else? So this number is prime also. What are the factors of 15? Okay, let's go with 3. Oh, I need to write them all down. My bad. So we're going to write 1 and 15 and 3 and 5. Okay? So what kind of number is 15? Composite. Has more than 2 factors. It's composite. And I spelled that wrong. There we go. 7, 8, and 9, it says write the prime factorization of each number. Use exponents for repeated factors. So I'm going to do my factor tree now. If you like the cake method and the cake method makes more sense to you, feel free to use that. Okay? I just like the tree. So what equals 18?
4, 3,
3 and
2,
nope.
4,
3 times what equals 18?
6.
6. So, can I break 3 down anymore? No, it's only 1 and 3, so we're going to leave that. Can I break 6 down more? 2 and 3. So my prime factors for 18 are going to be all these numbers that I can't break down anymore. So my prime factors for 18 are going to be 2 times 3 times 3. But the direction said use exponents for repeated factors. So I'm going to write the 2 because there's only one of them, but how many 3's are there?
2, 1. Yeah.
2 3's. So I'm going to use an exponent on my 3. How about 39? What can I multiply to get 39? Well, let's not use that when we're doing our prime factorization. We don't want to have 1 in there. So we're going to think of other things that equal 39. But I'm glad you brought that point up. That was really important. What else equals 39? 3 and something. 3 and what?
1,
3 times what equals 39?
3, 9, 4,
13.
13. Good. So, can I break 3 down anymore? No, it's just 1 and 3. Can I break 13 down anymore?
Yeah.
What equals 13? Nothing. So guess what? Those are going to be my prime factors. And I recommend circling your prime factors in your factor tree so you don't miss one when you're writing them down. So this time I have no repeated factors, so my answer is just going to be 3 times 13. Okay, so for 50, what equals 50? Let's go through.
2,
Yeah, 5. We can use 5 and 10. Okay, can I break 5 down anymore? No, so 5 is going to be one of my prime numbers. Can I break 10 down more?
Yeah.
To what?
2 and 25.
2 and 5. 2 times 5.
For the next one.
Okay. Well, if we could have started with 2 and 25 instead of 5 and 10,